Hello, everybody. So today we're going to continue with our fifth grade material, and today we're talking about division patterns with decimals. We're on page 209 of the fifth grade Go Math textbook. And so our essential question is, how can pictures help you place the decimal point in a quotient? So let's look at the unlock the problem. Healthy Wheat Bakery uses 560 pounds of flour to make 1,000 loaves of bread. Each loaf contains the same amount of flour. How many pounds of flour does the bakery use in each loaf of bread? And so, just a reminder of what we normally do when we look at a word problem. We're going to underline the sentence that tells you what we're trying to find out. And so that's always the sentence with the question. So we're trying to find how many pounds of flour the bakery uses in each loaf of bread. And then what are the numbers we need to use? Well, we know they need to make 500 or use 560 pounds of flour, and they're going to make 1,000 loaves of bread. All right, so we can use powers of 10 to help find quotients. Dividing by a power of 10 is the same as multiplying by 1/10, 1/100th, or 1,000th. So let's use place value patterns. So if we're going to divide 560, the total amount of flour, by the number of loaves, that'll tell us how much we're going to put in each, how much flour to put in each loaf. So let's look at these patterns. So if we had 560 times 1, we'd just say that's 560, right? Well, if we divide 560 by 1, we get 560. If we multiply 560 by 1/10, our decimal point would move one place to the left and we'd have 56. So 1/10 is the same as dividing by 10. 560 divided by 10 equals 56. So why is that true? Well, let's look at this. 560 times 1/10. Well, we know we can write 560 as 560 over 1. 560 divided by 1 is 560. So we learned in fourth grade that we can multiply straight across on fractions. So 560 times 1 is 560. And 1 times 10 is 10. So we can read this problem as 560 divided by 10. Okay, which would give us 56. So when we say multiply by 1/10, that's what we're doing, right? So which is the same as actually dividing by 10. All right, so 560 times 100th would be the same as dividing by 100. And so when we divide 560 by 100, we move the decimal point 2 places to the left. And 560 times 1,000th, we'd move the decimal point 3 places to the left. If we divide 560 by 1,000, we'd move 3 places to the left. So how many pounds of flour is used in each loaf? 56 hundredths or 560 thousandths pound of flour in each loaf. And those are equivalent decimals. So what are we doing? So as we divide by increasing powers of 10, how does the position of the decimal point change in the quotient? What's happening? Every time we increase by a power of 10. Here we moved it one place to the left. Here we moved it 2 places to the left. Here we moved it 3 places to the left. So it's going to move one more place, it being the decimal point, moves one more place to the left. For each increasing power of 10. Okay, so this was, in a sense, 10 to the first. And we moved the decimal point one place to the left. This was 10 to the second power. we wound up moving the decimal point 2 places to the left. 10 to the second is 1 power greater than 10 to the first. Here we only moved it once. Here we moved it twice. Here we're divided by 10 to the third power, and we moved the decimal point 3 places to the left. All right, so let's use that idea of exponents. So 560 divided by 10 to the third. Well, what is 10 to the third? 10 to the third is the same as 1,000. So 560 divided by 10 to the 0 power is just 1. So 560 divided by 1 is 560. 560 divided by 10 is 56. So 10 to the first tells you move the decimal point 1 place to the left. 10 to the second power, move the decimal point 2 places to the left. 10 to the second power, you remember, is equal to 100. And 10 to the third, well, that's going to tell me, so we had 560, right, when we were dividing by 1. So 10 to the third power, we'd move the decimal point 3 places to the left. So remember over here that the 0 power of 10 equals 1. 10 to the 0 equals 1. And the first power of 10 equals 10. So each divisor or power of 10 is 10 times the divisor before it. How do the quotients compare? So these are our quotients, right? So we had 560, then 56, then 5 and 60 hundredths, and then 560 thousandths. So what happened to the quotients? The quotients are only 1/10 as big not as big. Let's just say 1/10 of the previous quotient. Okay, because if I multiply 560 by 10, I'd get 5 and 60 hundredths. If I multiply 5 and 60 hundredths by 10, I'd get 56. If I multiply 56 by 10, I get 560. So each of these is 1/10 of the previous one. All right, so let's look at page 210. So we said dividing by 10 is the same as multiplying by 1/10, or finding 1/10 of a number. So let's use this example. Liang used 25 and 5/10 pounds of tomatoes to make a large batch of salsa. He used 1/10 as many pounds of onions as pounds of tomatoes. He used 1/100th as many pounds of green peppers as pounds of tomatoes. How many pounds of each ingredient did Liang use? So we know he used 25 and 5/10 pounds of tomatoes. He's going to use 1/10 as many pounds of onions, and he's going to use 1/100th as many pounds of green peppers. All right, so what do we know? The only number we really know is the tomatoes. But we do know that the onions are 1/10. And 1/10 is the same as dividing that number by 10. So 25 divided by 1 would just be 25 and 5/10. If we divide 25 and 5/10 by 10, our decimal point would move 1 place to the left. So it would be 2 and 55 hundredths. Now we also know that the green peppers are 1/100th. So he's going to divide by 100. So 25 and 5/10 pounds divide by 100. Again, if we're just looking at patterns, 25 and 5/10 would just be 25 and 5/10 if we divide by 1. If we take that same number and instead divide by 10, you'd move the decimal point 1 place to the left, and we'd have 2 and 55 hundredths. If we took 25 and 5 tenths and divide by 100, we take the decimal point and move it 2 places to the left. So we'd wind up with 0.255. So Ling used 25 and a half pounds of tomatoes, 2 and 55 hundredths pounds of onions, and 255 thousandths pounds of green peppers. Okay. All right, so let's try this pattern. So again, 36 and 6 tenths divided by 1. Any number divided by 1 is the other number. All right, so we have 32 and 6 tenths. Now, if we multiply by 1 increasing power of 10, we would take the decimal point in 32.6 and move it 1 place to the left, and we'd have 3.26. And that should make sense, because what if we had 30 and we divided by 10? 30 divided by 10 is just 3. So that gives us a clue that our decimal point has to be after the 3. Okay, and if we divide 326 or 300 by 3, actually it's not 300, right? It's only 32. So we'd be less than 1 here, right? 32 divided by 100 would be less than 1. So 32 and 6 tenths divided by 100, we would take the decimal point and move it 2 places to the left. And we have 326 thousandths. All right, so 50 and 2 tenths divided by 10 to the 0. Remember, 10 to the 0 is just 1. So that's going to be the same number. Okay, then when we divide by 10 to the first, take the decimal point, move 1 place to the left. And 10 to the second, take the decimal point and move 2 places to the left. Again, 50 divided by 100. 50 over 100 would be 50 hundredths, right? And that's kind of what we have here, right? We have 502 thousandths. But if we only looked at the hundredths, we'd have 50 hundredths. All right, number 1, just complete the pattern. So 10 to the first, we have the exact same number. 456 divided by 1, we move the decimal point 1 place to the left of the 6. 456 divided by 10 to the second, we move the decimal point 2 places to the left of the 6. 456 divided by 10 to the third. So that's our original number, and we have to move the decimal point 3 places to the left of 6. 1, 2, 3. So we get 0 and 456 thousandths. So in this problem, think the dividend is being divided by an increasing power of 10. So the decimal point will move to the left 1 place for each increasing power of 10. Okay, so let's just continue. Page 211, number 2. Just look at the patterns. So again, 10 to the 0 is just 1 whole. Well, that's going to give us the same number. We're not moving the decimal point at all. All right, but 225 divided by 10, 200 divided by 10 is 20, right? So we know that we'd have 22.5. 10 to the first means move the decimal point 1 place to the left. 225 divided by 10 to the second means move the decimal point 2 places to the left, and we'd have 2 and 25 hundredths. And 225 divided by 10 to the third, move the decimal point 3 places to the left, and we'd have 225 thousandths. 605 divided by 10 to the 0, that's just 605, because this is 1. 10 to the 0 is 1. 605 divided by 10 to the 1, 10 to the first. Move the decimal point one place to the left. 605 divided by 10 to the second. Move the decimal point 2 places to the left. 1, 2. 605 divided by 10 to the third. Move the decimal point 3 places to the left. 774.3 divided by 1 is that number. 74 and 3/10 divided by 10. Move the decimal point 1 place to the left. 74 and 3/10 divided by 100. Move the decimal point 2 places to the left. Okay, number 5. So we just keep on working. We're just working on the patterns here. 156 divided by 1 is that number. 156 divided by 10, we'd move the decimal point 1 place to the left. 156 divided by 100, we'd move the decimal point 2 places to the left. 156 divided by 1,000, move the decimal point 3 places to the left. 32 divided by 1 is 32. We're not going to move the decimal point at all. 32 divided by 10, move the decimal point 1 place to the left. And we have 3.2. 32 divided by 100, move the decimal point 2 places to the left. And we have 32 hundredths. 32 divided by thousandths. 1, 2. Now here, I don't have enough decimal places to move 3 places to the left, so I'm going to have to add a 0. Okay, because if we're here, we're just moving, that would be 1, 2, but I have to move it 3 places. So it would be 0.032. Okay. All right, 7. 16 divided by 10 to the 0. Again, we know 10 to the 0 is just 1. So it's just going to be 16. 16 divided by 10 to the first. We're going to take the decimal point and move it 1 place to the left. 1 and 6/10. 10 to the second. Move the decimal point 2 places to the left. 16 divided by 10 to the third. We're going to move the decimal point 3 places to the left. 1, 2. Since we don't have the third spot, we have to add a 0 and then move it. So 0.016. 12 and 7/10 divided by 1 is that number. 12.7 divided by 10. Move the decimal point 1 place to the left. 12 and 7/10 divided by 100. To move the decimal point 2 places to the left. And we get 127 thousandths. All right, number 9. 92 and 5/10 divided by 1. 10 to the 0 is 1. We'd get 92 and 5/10. 92 and 5/10 divided by 10 to the first. Move the decimal point 1 place to the left. 9 and 25 hundredths. And 92 and 5/10 divided by 10 to the second power. Move the decimal point 2 places to the left. And we'd have 925 thousandths. Number 10, 86 and 3/10 divided by 10 to the 0, which is 1, is 86 and 3/10, the same number. 86 and 3/10 divided by 10 to the first power means you're going to move the decimal point 1 place to the left. And we'd have 8 and 63 hundredths. And 10 to the second power, we'd move the decimal point 2 places to the left. and we'd have 863 thousandths. All right, look for a pattern, and we're using algebra. We're finding the value of n. And again, it's simply some unknown value. It could be any letter or symbol. So we're starting at 268. Divide by something, and we notice that we are wound up with 0.268. Well, we started with 268. How many places did the decimal point move to the left? It moved 1, 2, 3 places to the left. So n has to be 10 to the third or 1,000. Number 12. So some number divided by 10 to the second gives me an answer of 0.123. So when I divide by a number by 10 to the second, that means the original number was 2 places to the right. So we're saying 123 times 100. The opposite of division is multiplication. So if we're dividing some number by 10 to the second power, then the product is the same as would be the same as multiplying the product by by that factor, by the divisor. So 123 thousandths times 100 would tell me to move the decimal point 2 places to the right. So we would have 12.3. Let's see if that makes sense. If we have 12.3 divided by 10 to the second, that means move the decimal point 2 places to the left, and we'd have 0.123. So that is correct. All right, number 13. Some number divided by 10 to the first is 4.6. Well, again, this would be the same as taking the product and multiplying by the divisor. So 4.6 times 10 to the first would be 46. We would take the decimal point and move 1 place to the right when we multiply. So n equals 46. If we put that here, we have 46 divided by 10 to the first. We would wind up moving the decimal point 1 place to the left. So that would be correct. So 46. Now let's look at page 14. Use the table to solve problems 14 through 16. So our table says that we have some dry ingredients for 1,000 corn muffins. So if you make 1,000 corn muffins, you would use 150 kilograms of cornmeal. You would use 110 kilograms of flour. You would use 66 7/10 kilograms for 1,000 corn muffins, baking powder 10 kilograms, and salt 4 17/100. Okay, so about how much more cornmeal than flour? About how much more cornmeal than flour does each muffin contain? So cornmeal is 150 divided by 1,000. Flour is 110 divided by 1,000. So why are we divided by 1,000? Because we're finding out how much cornmeal would be for just one. So we have to divide by 1,000. All right, so 150 divided by 1,000 means move the decimal point 3 places to the left. So 1, 2, 3. So 150 thousandths. So if we're taking 110 and divided by 1,000, move the decimal point 3 places to the left, and we'd have 110 thousandths. So then if we're going to subtract that, right? Because it says about how much more. So if we subtract, we get 0.040. So we could write that as kilograms more, or 0.04 kilograms more. These are equivalent numbers. Okay, so either way would be correct. All right, so if each muffin contains the same amount of sugar, how many kilograms of sugar to the nearest thousandth are in each corn muffin? So sugar, we have 66 and 7/10 kilograms of sugar. And so if each muffin contains the same, we have to figure out how much would be in just one corn muffin. So we're going to take 66 and 7/10 and divide by 1,000. Dividing by 1,000 means move the decimal point 3 places to the left. Well, I don't have enough spaces to move it 3 places to the left. So I'm going to add a 0. So we get 0.0667. But it says to the nearest thousandth. Well, that means we'd have to round this, right? Because we're rounding to the second 6, which is in the thousands place. The 7 tells me to round up, so it'd be 0.067 kilograms per muffin. Okay, the bakery decides to make only 100 corn muffins on Tuesday. How many kilograms of sugar will be needed? Well, okay, so if they're only making 100, that's 10 to the second, right? Before they were making 1,000, which was 10 to the third. So how much bigger or how much smaller is 100 than 1,000? It's just 110, right? 10 to the first. So we're going to take that 66.7 and we're going to divide by 10. Okay, because 100 is 1/10 as big as 1,000. So if we're going to divide by 10, we're just going to move the decimal point 1 place to the left. And so we'd have 6 and 67 hundredths kilograms. Would be needed for 100. All right, now 17. Explain how you know that the quotient 47 and 3/10 divided by 10 to the first power is equal to the product of 47 and 3/10 times 1/10. Okay, well, 10 to the first is 10, right? And 1/10 would be like dividing by 10. So when I divide by 10, the decimal point is going to move 1 place to the left. When I multiply by 1/10, the decimal point is still going to move 1 place to the left. So both are equal to 4.73. 10 to the first, move the decimal point one place to the left. You get 4 and 73 hundredths. Multiply it by 1/10, we'd still be moving the decimal point one place to the left, and we still get 4 and 73 hundredths. All right, last one, 18. Use the numbers on the tiles to write the value of each expression. 62 and 4/10 divided by 10 to the 0, which we know is just 1. So 62.4. 10 to the first, take the decimal point, move one place to the left. 6 and 24 hundredths. 10 to the second, move the decimal point two places to the left. And we have 624 thousandths. Okay, so that's it for lesson 5.1. In our next lesson, we're going to work on dividing decimals by whole numbers. So until then, I will see you soon.